I have started, essentially. I've got the piece of wood. I'm going to cut out the table today. I've got all the bits and parts, with the exception of 2 bolts. It's going to be a nifty little machine. I've got the whole thing designed. It's just a matter of doing it now. Got the table saw ready. From here on, it's just a matter of building the darn thing. Here we go. This is my basic layout for my machine. This is going to be the top surface. Now I'm going to get a piece of hardboard that is about 1 inch longer on all sides except the back. It's going to be flush with the back. It's going to be 14 inches wide, 13 inches long. Hole cut in the same spot for the wire. And it's going to be the actual surface. The reason I'm going to put that on it is so I have a clamping edge, because the back, the front, and the sides are going to fit flush and make a box similar to this. So that's the layout. This is the only this and this, and a little bit off the edge. It just happened to be about 1/4 inch longer than it advertised, which is cool. But this and this are the only scrap. Well, the rest of the sheet, but it's not scrap. I have plans for it. It'll work out just fine. Okay, what you're looking at is the back of the box. This is going to mount here like this, the little arrow pointing to what degree we set it at. The upright is going to mount onto it like so, giving me a grand total of an 8-inch rise, and then 8 inches deep, and that's where the hole will go. I had some little squiggly wire pieces, and I wanted to use them for this project, so this is going to attach to the arm. It's going to provide the electricity to the wire. Then there will be a switch here, which will come into the front here. And I got these 2 little L brackets that I've modified slightly, and they will hold, I don't know why I decided to use 2 of them, but I did. Well, I'm going to go through, there we go. They will hold the eye bolt there with the electricity into it. So that's going to be cool. This is going to mount to the bottom of the top part, and everything will be wired through. So okay, here we have it. It is finished. Got the wire here. Now it's 32 gauge. Now I could have used so much thicker than 32 gauge. And I think if I ever have to redo this, I'll not only go thicker than 32, but I'll probably also use a thicker arm. Just, it's so flimsy, you can see just the slightest movement sends it nuts. And just, you know, fooling around, I cut a test piece, and you can see in some spots where I got undercuts, because I pressed on the wire, and it just bent, you know, undercut like that. So what I'm going to have to do is make 2 forms to cut the pieces with, and that'll ensure a straight cut every time with the thinner wire. So yeah, but here's the machine. I got my got me a little wall wart plugged in there, powering the darn thing. I got kind of creative. I had some squiggly wire. I hooked that up. You see this U channel here, I can loosen this and I can tip it, get a bevel on it. Here's my plug in here. You can see the wiring here in the bottom. I pulled this out of something, I don't even remember what. It's been in my parts bin forever. I soldered wire to the end. The wire splits, goes to the switch. From the switch to the eye bolt here underneath that goes to the wire, which runs to that, which comes into the squiggly cord, which goes into the other, to the negative. So there's all the electronics. It's super duper simple. I had to do some calculations. I had to test the resistance of the entire circuit, and I had to go online and look up the required amperage to drive the wire at various temperatures. It needs 0.63 amps at what was it? 0.63 amps at 400 degrees, and for every incremental increase in amperage after that, you get a higher temperature. Right now, I've got it hooked up to a power supply that's pumping out 12 volts at 1 amp. So, a little quick conversion there, turn everything into wattage, and figure out your wattage, you know, the watts that the whole thing would use. I know that's not exact parlance there, but I did it and it works, so I'm happy. I did use nichrome wire. Now, I ordered 20 feet of 32 gauge nichrome wire for about $6. No, it wasn't even $6. I got this for $2 on eBay. That's including shipping. And it's pretty cool because they sent me a sampler of all their different gauges. They go down to 44 gauge. You can't even see it. I mean, it's so thin, it's amazing. But it's all nichrome, so it heats evenly. And I got enough so that if it breaks or wears out, I can replace it. Replace it 20 times over. So there you go. It's an 8-inch rise here from the bed to this, and then another inch down. So I'm using about 10 inches total, 9 or 10 inches for the entire piece of wire. So, I mean, the board's half-inch thick, and the U-bolt, the eye-bolt, I mean, is you know, a 1/4 inch from it. So it worked out real nice. All right, anyone watching may or may not be familiar with foam cutters, different types of foam cutters. There's handheld foam cutters, battery operated, plug-in, all different types. Well, I saw a couple different designs for professionally made ones, and I decided I can do the same dang thing. So what I'm going to do is I'm going to design and build. I'm going to make a handle out on the vacuum form machine, and then I'm going to design the electronics to fit inside it, and I'm going to make a pair of arms out of this, and I'm going to make a hot wire foam cutter that is adjustable and with interchangeable parts, and I'm going to use 20 gauge nichrome wire, and I'm going to have just a small blade, 2 or 3 inches long, with a rounded tip, pretty narrow, and I'm going to use that to do hand carving. So that'll be my next project. You should be able to watch that over the next week or so. Waiting on that wire, and of course the power supply. And design the machine with the same type of power plug as this, so I can use the same power supply. Just don't plug the power supply from that, plug it into the other thing. I considered having an input and an output on this so that I could just plug it in and have like a bypass circuit so that when that was on, this was on. But I thought the better of it. I thought that it'd be better if I had a separate power switch on the tool plus, you know, a separate plug, so I wouldn't have to worry about rewiring anything. Just made it easier. Project. As far as big projects go, I've been working on the bucks for my vacuum former, and I needed the hot wire cutter to cut out the foam to make the bucks. So I had to build that, and the wire just came today, which is today's Saturday. So I was able to finish that up today, and it works. I've been playing with it. The wire's a little thin. It takes it cools quickly, so when I put the foam to it, it tends to want to move. You see how thin it is, it just moves. And this, being as flimsy as it is, it's easy to flex. So I don't know, I may soon in the future go to a thicker wire here, a thicker gauge arm, and that way I can stretch the wire a little tighter. But yeah, that's my projects.